Types of chemical reactions. A large number of different types of chemical reactions occur which can be distinguished from one another. Although some of these reactions are interrelated, but they may be classified on the following basis. So first one is reactions among similar atoms and molecules. B is reactions among different kinds of atoms and molecules. And C is miscellaneous reactions. So let's first discuss the reactions among similar atoms and molecules. So these kind of reactions are further categorized into different types, in which first one is association. In such reactions, two or more molecules combine together to form large aggregates. There is no change in the chemical characteristics of the substance as a result of association. For example, water is an associated liquid in which water molecules are associated to form the H2O linked aggregated system through hydrogen bonding. Due to this reason, water is a liquid but hydrogen sulfide is not, because the later molecule does not associate. As the oxygen and sulfur belongs to same group, they must have similar properties according to periodicity, but here the role of association, in which different water molecules are interconnected to form a linked structure. So these water molecules exist in a form of liquid, whereas H2S is the gas where all the molecules are isolated. So in this way, the water molecules are associated through hydrogen bonding. Whereas different hydrogen sulfide molecules exist as isolated forms in a form of gas. The second type is dissociation. This process involves degradation of the molecules, and the dissociation process are of two types. The first one is thermal dissociation, and the second type is ionic dissociation in solution. So now let's discuss the thermal dissociation. In thermal dissociation, the substance decomposes on heating but produces the same substance upon cooling. For example, when ammonium chloride is heated, it will produce ammonia and hydrogen chloride gas, and when this mixture is cooled, it will generate the ammonium chloride. So in this process, upon heating, the chemical substance has been dissociated into its components, which is the reversible process. Another example is the dissociation of phosphorus pentachloride into phosphorus trichloride while releasing the chlorine gas, which can be reproduced through cooling. So thus the dissociation is a reversible process in which dissociation produces the products which are in equilibrium with the dissociated substances. The second kind of dissociation is known as ionic dissociation. In ionic dissociation, the substance breaks into cations and anions. For example, if we have sodium chloride crystal which is dissolved in water, it will be dissociated into sodium and chloride ions. And when this water is evaporated, the crystals of salt can be obtained on removing the solvent. The third kind of chemical reaction is known as decomposition. In this reaction, the molecules of the substance breaks up into two or more molecules irreversibly. For example, we have potassium chloride which is decomposed into potassium chloride and oxygen. Another example is decomposition of the lead nitrate into lead oxide, nitrogen dioxide and oxygen gases. Here lead oxide is solid, potassium chloride is solid, and these two molecules are also solid. The fourth kind is disproportionation reaction. It is a kind of reaction when a compound undergoes simultaneously the oxidation and reduction reactions due to its variable valency. In this kind of reaction, a compound breaks up into two new substances, one containing element in the lower valency and the other having higher valency. For example, in this case, the valency of each chloride ion is -1. For 2 chloride, the overall valency of negative species is -2, and here the valency of copper must be +2. For each copper, the valency is +1. Whereas in this case, for each chloride, the standard valency is -1. For 2 chlorides, the negative charge on the negative species is -2 for 2 chlorides. So here the valency of copper is +2, and we observe that the compound copper 2 chloride have undergone simultaneous oxidation and reduction reaction due to its variable valency. Here the valency of the copper in pure state is 0, and in this reaction the copper 1 have been oxidized to produce copper +2 and reduced to generate copper. So at a time this copper 1 have been reduced and oxidized simultaneously. In another example, gold chloride is oxidized and reduced to gold 3 and pure gold states. The fourth kind, other kind is the condensation reaction. This kind of reaction represents the formation of more complicated molecule by the combination of two or more simple molecules with the elimination of water. the combination of two phosphoric acid molecules to form a pyrophosphoric acid with the elimination of one molecule of water is a typical example of condensation reaction. Similarly, two molecules of sulfuric acid condense to form pyrosulfuric acid. Next type of reaction is polymerization, and this process is said to take place when a large number of small molecules of the same kind combine to form a large macromolecular product or polymer. For example, the ethylene that polymerizes to polyethylene polymer. Similarly, sulfur trioxide forms a trimer, that is SO3 Phosphorus pentaoxide makes a dimer, sulfur trioxide is making a trimer, and for polymer, n number of same kind of molecules combine to form a macromolecule. So here n is very large, that can be greater than 3. Depolymerization. Depolymerization is a reverse of process of polymerization in which polymers break down to simple repeating units that can be dimer or monomer. Like for example, if we have a dimer, it will depolymerize to a monomer. So simply we can say that a polymer or a complex molecule breaks up to give two or more molecules of the same type. Another kind is isomeric rearrangement, in which the atoms in the molecule of a substance undergo a rearrangement, producing a new substance of same composition but having different properties. The conversion of ammonium cyanide into urea by heat is a typical example of isomeric change. Here the functional groups of the ammonium cyanide is cyanide, and here we have carbonyl group. Now let's discuss the reaction among different kind of atoms and molecule, in which the first one and the most important is synthesis. Synthesis is a combination of atoms or molecules to produce a new compound is known as synthetic reaction. For example, formation of iron sulfide. On heating, iron and sulfur is an example of synthetic reaction. Copper carbonate is usually synthesized with the reaction of copper oxide and carbon dioxide. Second kind is substitution or simple displacement, and in this process one element displaces or substitutes another element from a compound. For example, when zinc is reacted with sulfuric acid, it replaces the hydrogen of the sulfate group to make zinc sulfate, and hydrogen will be generated. Similarly, iron can replace copper from copper sulfate to make ferrous sulfate. So this is simple substitution or simple displacement reaction. Another type is double decomposition. This process is similar to the substitution or simple displacement, but here the process involved the mutual displacement of atoms from reacting species. For example, in this reaction the nitrate of silver will make the sodium nitrate, and chloride of the sodium chloride will go to silver to make silver chloride. Neutralization. acid and bases react with one another to form salts, and the solvent molecules are given out. Thus, the neutralization of sodium chloride is obtained from the neutralization reaction between the hydrochloric acid and sodium hydroxide. So this one is acid and sodium hydroxide is a base that undergo a neutralization reaction to generate a salt and solvent molecule. In another example, in liquid ammonia, as a solvent, ammonium chloride acts as an acid, whereas ammonium chloride reacts with a base known as sodium amide to generate sodium chloride salt and solvent molecule. Solvolysis is a reaction that is generally defined as a process in which an ion reacts with the solvent to form products containing cations and anions of solvent. For example, if you dissolve sodium carbonate to water, the hydroxyl ion of water will attach to sodium to make sodium hydroxide, and hydrogen ion will go to carbonate to make carbonic acid. Another example is mercury chloride that is reacted with ammonia, that is NH3. So here if we draw the structure in this form, so we can see that how the solvent, that is ammonia, is broken to cations and anions, that is NH2 minus and H plus, to generate two different products in which two products are obtained from the cation and anion of the solvent that have been generated through the solvolysis of the solvent. Now we are going to discuss the third type, that is under the category of miscellaneous reactions. Large number of chemical reactions cannot be classified and may be discussed separately, and some of them are of great importance in chemistry and discussed as so first one is addition reaction. Such reactions involve the addition of atoms or molecules to unsaturated molecules containing double or triple bonds. This addition of hydrogen to ethylene to form ethane is an example of such type of reaction. So here the unsaturated hydrocarbons have ability to add new atoms to make saturated hydrocarbons. carbons. So here ethylene is reduced to ethane through addition of hydrogen in the presence of a catalyst. So this kind of reaction is known as addition reaction. Pyrolysis and cracking process include the breakdown or decomposition of the large macromolecules to small molecules. The typical example of cracking of higher petroleum hydrocarbons to lower petroleum products containing lower hydrocarbons in the formation of gasoline. The crude oil is undergone through a process of pyrolysis or cracking to produce gasoline. Chain reactions, as the name indicate, these reactions include such processes in which the products of the reactions initiate, like in the presence of light, chlorine can generate the chloride radicals, and these chloride radicals can carry the reaction further, and these radicals generate other kind of radicals like hydrogen radical, and these two kind of radicals start a chain reaction as shown here. Catalytic reactions, such type of reactions takes place in the presence of catalyst which remain unchanged at the end of the reaction. Some reactions do not proceed smoothly or are too slow in the absence of these catalysts. However, these catalysts or catalytic agents can accelerate or retard the rate of chemical reaction. For example, we have the synthesis of ammonia, which is carried out in the presence of tungsten or iron catalyst. Whereas another example is the sulfur dioxide that can be only converted to sulfur trioxide in the presence of either platinum or vanadium pentaoxide catalysts, which is an important reaction for the synthesis of sulfuric acid. So the other type is endothermic and exothermic reaction involving the absorption or evolution of heat during the reactions. For example, for the reaction of hydrogen and iodine to generate hydrogen iodide, a constant supply of heat is required. So this reaction that is accompanied by the absorption of heat are known as endothermic reactions. And reaction of this type require a constant supply of energy from outside to let them go smoothly. Other reactions accompanied by the evolution of heat are said to be exothermic reactions, and they are also known as spontaneous reactions. So the burning of magnesium or carbon in the presence of oxygen generate the oxides like magnesium oxide and carbon oxide with generation of heat energy are known as exothermic reactions. Oxidation and reduction reactions are also known as redox reactions. The reactions involving electron transfer are called oxidation, reduction reaction or redox reactions, and every oxidation process is accompanied by the reduction or oxidation, the loss of electrons or gain of positive charge is known as oxidation. Loss of electron whereas reverse is true for the reduction. Like conversion of iron 2 plus to iron 3 plus is a process of oxidation, whereas the gain of electron in which chlorine radical is converted to chloride ion is known as the process of reduction. The last kind is electrophilic and nucleophilic reactions. Both